Hey students, it's me, Mr. Fitz. So I just wanted to take a few minutes to talk about right triangle trigonometry and specifically how you find missing sides and missing angles in right triangles. And we're going to look at some problems that come up in Delta Math. So here it goes. Hopefully this will help. Let's take a look. So first off, we're going to look at using trigonometry to find missing sides. And so here's the first problem. In triangle RST, the measure of angle T equals 90. And the measure of angle R is 24 degrees, and RS equals 3.8 feet. Find the length of ST to the nearest tenth. 3.8 feet, that's a big triangle. I'm pretty sure they give you the diagrams on these, but if not, make sure you draw the diagram. So angle R is the 24 degree angle here. So this is going to be our reference angle, remember? So this is our starting point. This is our starting angle. So this is our point of reference. Here, 3.8 they gave us, that's the hypotenuse. Remember, the right angle points to the hypotenuse. So the first thing I do is I label my opposite side, my adjacent side, and the hypotenuse. So if this is my reference angle, I'm connected to this side, that's my adjacent side, and then staring at me across the way is this side here, and that's my opposite side. And then I also write down this, SOHCAHTOA. You're going to hear me say this a lot. So this represents those trig functions we just learned about. So the sine of the angle measure equals the length of the opposite side over the length of the hypotenuse. The cosine equals the adjacent side over the hypotenuse, and the tangent equals the opposite over the adjacent. So the length of those sides. So SOHCAHTOA. So in this case, I'm going to use sine. Why? Well, let's take a look. They gave us the hypotenuse. So that means I need to use one of these two because I know the hypotenuse. So it's either going to be cosine or sine. But I'm looking for ST. So that's the side I'm looking for. So I have to use sine because I'm looking for the opposite side. And remember, it's all dependent on our reference angle. If they gave us this angle, it would be flipped around, right? Then this would be our opposite side and this would be our adjacent side. So since they gave us angle R, that's what I'm going to use. The opposite side over the hypotenuse. So I'm going to go ahead and label this R, because that's what I'm looking for. That's kind of the convention, right? We name it like use the lowercase letter for the opposite side. So this is lowercase r, represents the length of this side. So the sine of 24 degrees equals r over 3.8. Well, how do I figure out what r is? Well, I have to multiply both sides by 3.8. Therefore, I'm left with this, 3.8 times the sine of 24 degrees equals r. This is just a number, right? So I'm just plugging in sine of 24 degrees, and it's going to give me some ratio of side lengths. It's going to give me a decimal. So let's just take a look. I'm going to plug this straight into my calculator, and I'm going to show you how to do that right now. So I'm going to use my graphing calculator first, and then I'll show you how to do it on the Delta Math calculator. So let me just pause the video for a second and pull up my calculator and hold on. Okay, so here's my graphing calculator. And so the first thing you're going to want to do is make sure you're in degree mode. We're not going to use radians in this class. So you go to your calculator and it defaults to radian mode, and that's just a different angle measure. So like, centigrade and Fahrenheit or feet and meters, there's just a different unit of measure. But we want to use degrees. So I'm going to go over and scroll over here, hit enter, make sure I'm in degree mode. If the batteries pop out of your calculator, you're going to have to just make sure you're in degree mode. All right, so let's go back. Now I'm in degree mode. So this is what I want to plug into my calculator. It's just 3.8 times the sine of 24. So here's sine of 24. Close my parentheses, enter, and I get 1.5455. So I want this to the nearest tenth. So let's go ahead and I'm going to hit math, number, round, second, little minus sign. So I'm going to pull up the answer, previous answer, close that. Oh wait, no, hold on. I want to round that to the nearest, what, tenth? That's one decimal place. So I don't want to make any rounding errors. 1.5. So that's a common rounding error I see, is students will look at this and they'll say, oh, 1.54, but this number is 5, so I should round this one up and then round the next one up. No, that's a really common mistake. So you always just look at the next decimal place, and since this one is a 4, we round down. If I was rounding to the nearest 100th, then I would actually round it up. So that's a little confusing, I know, but you're always just going to look one decimal place out. So there you go. That's this one, and then we'll look at one more. So let's take a look at this one. In triangle BCD, the measure of angle D is 90 degrees, and the measure of angle B is 22 degrees, and DB equals 44. Find the length of BC to the nearest tenth. So let's take a look at the diagram. I just sketched it out. So angle B is our reference angle in this case. Whoops, didn't want to draw on that. So angle B is our reference angle, and it's 22 degrees, and I'm going to go ahead and label everything. So here's my opposite side. I labeled that with a lowercase b. Here's my adjacent side, right? That's the one connected to angle B, and that's lowercase c. And then here's my hypotenuse. Remember, the right angle points to the hypotenuse. So, and then I'm also going to write out SOHCAHTOA, so I remember all of my trig ratios. So I'm going to use cosine in this case. Why? Well, here, I'm actually looking for BC, which is the hypotenuse. I'm looking for that. So I need to actually use either of these two because that's the one thing I'm looking for. And then what did they give me? They gave me the adjacent side. So I know this is my reference angle, and they gave me the adjacent side. So it's adjacent over hypotenuse. So the cosine of angle B equals the length of the adjacent side over the length of the hypotenuse. Or that could be like lowercase c, which is this length, over lowercase d, which is the hypotenuse here. So I'm going to go ahead and rewrite that. Cosine of 22 equals 44 divided by d. All right, this is kind of weird because my variable is down here. So I need to find what d equals in this case. So I can set this up as a fraction because cosine of 22 is just a number, and then cross multiply. So cosine of 22 over 1 equals 44 over d. Cross multiply and you get d times cosine of 22 equals 44. But I want this lowercase d by itself, so I'm going to divide both sides by cosine of 22. And what do you get? The length of the hypotenuse is 44 divided by the cosine of 22. So this is a little trick that I like to use. See here how the variable, the thing I'm looking for, is in the denominator? When I'm cross multiplying, I end up dividing by the trig function. If the variable were here in the numerator, you end up multiplying by the trig function. So that's a little thing. Once you get used to like doing all of these and you see like hundreds of them, you'll see like, oh, you see this pattern, and you'll be like, oh, then you can solve them a little faster. So there you go. The length of the hypotenuse is 44 divided by the cosine of 22. So I'm going to show you how to do this in the Delta Math calculator. A little different than the graphing calculator, so I'll just show you that. Let me just pause the video real quick and bring that up. So lucky me, I ended up with the same problem. The diagram's a little bit different, but that's okay. So here, let's take a look. Yes. So let me scroll down a little bit. And then here, I want to bring up the calculator. So I'm just going to click on this little thing here, and it brings up the calculator. And in order to get, so what was it? It was 44 divided by the cosine of 22. And look here, this is my adjacent side, here's my hypotenuse, so I know I need to use cosine, and I'm looking for the hypotenuse, so I'm going to end up dividing by the trig function. So it's functions, cosine, I'm going to go back, and you don't have to worry about degree mode because it's defaulting into degree mode here. Cosine of 22. Oh no, hold on. That's not right, right? Because I'm dividing by the trig function. So let's go back. So it was 44 divided by cosine of 22 degrees. Close my parentheses. There's my answer there, 47.45, and I need this to the nearest tenth. Well, here, since this number is a 5, I'm going to round that up, so that's 47.5. Let's go ahead and plug in our answer. Hopefully that's right. Am I sure? Yay, winner, winner, chicken dinner. So there you go. It shows you all of your work as well. It did the exact same thing I did. So there you go. Please make sure you check the Delta Math work as well. So let's look at one more and on how to find angles, and let's take a look at that problem now. Okay, so let's look at this problem. So we want to find an angle now. So in triangle STU, Stu, I had a good friend named Stu, the measure of angle U equals 90, US equals 5.9, and TU equals 2.6. Find the measure of angle T. Okay, well I've labeled everything here. I had the diagram. So I'm looking for the measure of this angle now. So let's see. This is going to be my reference angle. So whatever the angle that is I'm looking for, that's now my reference angle. So they've given me the opposite side and they've given me the adjacent side. So I don't care about the hypotenuse. I don't know anything about the hypotenuse. I'm not looking for the hypotenuse. So I'm going to use tangent. So here's my good friend SOHCAHTOA. So tangent. I know my opposite side. I know my adjacent side. So that's how I'm going to set up my trig functions. So the tangent of angle T equals the opposite side over the adjacent. Or I could call that lowercase t over lowercase s. So the tangent of t equals 5.9 divided by 2.6. But I don't want the tangent of t because this is the tangent of t. I just plug this into my calculator. I'm going to get some like weird like decimal thing, some mixed number, but I want the actual angle measure. So in order to do that, you have to take the inverse function. So think of it as like, what is the inverse operation of multiplication? Division, right? So if I'm multiplying two numbers, I divide both sides by that number, you know, and to figure it out. Or like, what's the inverse operation of addition? It's subtraction. So what do I want to do here? I want to do the opposite of this tangent function. So there is an opposite, an inverse function, and it's called arctangent. Or if on your calculators, you'll see it's like, looks like a little tan to the -1 power, but it's not raised to a power. This is just actually, think about it as actually with negative exponents, you're actually dividing, right? So it's like the inverse operation. So it's the exact same thing, only we won't really call them exponents here. This is just the inverse operation of tangent. So I'm going to take the inverse tangent of both sides. So it's inverse tangent of 5.9 over 2.6 equals t. Why? Well, these two things cancel out. So I'm just left with t equals the inverse tangent of 5.9 divided by 2.6. Now I'll show you how to plug that into your graphing calculator. It's not too bad. And I'll also show you how to plug it into the Delta Math calculator as well. So let me pause the video and do that. Okay, so here's the problem. And again, we want to make sure our calculators are in degree mode. So I'm going to go here and go to mode, go over to degree, hit enter. All right, good. I'm in degree mode now. Now, what do I want to enter into my calculator? I want to enter in inverse sine, or known as arc sine. So in order to do that, I hit the second button and then tangent. See over above the tangent, it has tan, inverse tangent. Inverse tangent, and then in parentheses, 5.9 divided by 2.6. 5.9 divided by 2.6. Close my parentheses, hit enter. Measure of angle T, 66.21. I think it wanted it to the nearest tenth, so I get it, round that to the nearest tenth. I'm pretty sure it wanted it to the nearest tenth. Sometimes it wants it to the nearest degree. If it's the nearest degree, you would round it to 0 digits. In this case, I'm going to round it to 1. 66.2 degrees. So that's the measure of this angle. It's 66.2. So let's take a look in Delta Math, how we would use the Delta Math calculator. So let me bring the Delta Math calculator, Delta Math problem up. Here it is. Exact same question. I think it might be drawn a little differently. That's okay. So, calculator. And I want funcs. Oh, here, I want to clear that out because I don't want the previous problem in there. And then here, inverse tangent, here it is, of 5.9 divided by 2.6. Enter. 66.217. And yes, I wanted it to the nearest tenth, so that's 66.2 degrees. Let me go ahead and plug that in. Here, I'll bring the calculator back up so you can see it. Oh, it's gone. 66.2. Submit my answer. Yay, I got it right. So again, I'll plug that back into the calculator, see how I did it. Funcs, inverse tangent, 5.9 divided by 2.6. And you get 66.2. Excellent. All right, that's all I have for today. I hope this helps. Thanks for watching, and please let me know if you have any questions. We'll talk to you later.